Welcome to, I'm calling it Unit 5. It's kind of similar to the unit we've already done, um, but we're going to talk about graphing inequalities. So we've been graphing systems of equations, and we've already graphed inequalities where we do a solid line or a shaded line, or sorry, a dotted line, and then we shade. And so we're kind of adding those two together for this next unit. So a system of inequalities is made up of at least two inequalities in a shaded region. So you're going to ask me like, oh, do I have to shade it? Yes, you do. You absolutely have to shade to make this accurate. So a new vocabulary word is feasible region, and that's basically that's just the shaded area. Sometimes it includes the line. Sometimes can include the line. Okay, sometimes it does, sometimes it doesn't. The vertex is the point where they intersect. So we've been calling this the solution where things intersect. Okay, so similar idea. So how do you graph this inequality? This is a reminder. So one way that we've been doing this is we've been solving for y. So I'll do that method. You guys like that one? The problem with this, and it's not really a problem, is that when you divide by a negative number, you need to make sure you flip the sign. And then I'm going to reduce my fraction plus 1/3 x. So I'm going to put a dot at -3, and then I'm going to go up 1 over 3, up 1 over 3. Okay, and then I decide, remember we have these open and closed circles. Remember we have solid lines or dotted lines. So we look and we decide our symbol is has an equal to. So I'm going to choose to make a solid line. That was a really bad one. Again, super bad. Let's try it. Okay. And then the last step is to shade. So we like to test 0, 0. So that's one way we've been doing this, plugging it in. Is 0 greater than or equal to -3? I plugged it in right here. Okay. 0 is bigger than -3, so this side is true. So we would shade this side. So this is your like reminder. How do we do that? These are the steps we take. So now when we get to our examples, and remember when you're watching a video at any point that I'm moving too fast, you should be pausing. When we get to this, we're going to graph two lines, and then we're going to shade, and then we're going to find the vertex or where they meet. So a couple different things that we've talked about. So 3x plus y is less than -3. I'll do this one in orange. I'm going to subtract 3x from both sides so that I have a y equals equation. It's not really equals, right? It's an inequality. So this one I'm going to shade in orange. Okay. And I am going to use a dotted line. So I'm going to put a dot at -3. And then I'm going to go, because it's negative, I'm going to go down 3 over 1. And if I go backwards, I can go up 3 and over 1. And I do have a dotted line, so I can use my dotted line tool. And you guys have a dotted line tool on Cami. Ooh, that was a crooked dotted line. Try one more time. So make your dotted line. Okay, and then I'm just going to use orange to shade. I'm going to test a point. Remember, we like to test 0, 0. So if I test is 0 less than -3, that would be false. Okay, so here's 0, 0. So because it's false, I want to shade on this side. And right now, honestly, I'm going to shade really lightly because something that happens is I have to shade the overlap. Okay, so I'm going to use a different color for my next one. So y greater than 3. A y line is a left and right line horizontal. And so I want it at +3. And this one is also going to be dotted. So let me get my dotted line tool out again. And at +3, I'm going to make a dotted line. Okay. And then I'm going to ask myself what types of numbers are greater than 3, and that would be numbers above 3. So I'm going to shade this way. Okay, so what's important here, let's maybe make a little checklist. Let me go back to my pencil. 1, you're going to graph and shade each line. And I'll put lightly. Like if you're using a pencil, sometimes I just make little arrows. Because what I want now is the feasible region. FR is the shaded overlap. Okay, so when I look at my picture, where do I have any overlap? And let me pick, let's do like blue. My overlap is this chunk right here. Okay, and because I shaded lightly or used my eraser tool, I can kind of go like this, right? Because I didn't make a bunch of big colorful lines. So this is my feasible region. Okay, and then this right here is my vertex where they meet. And so how do I do that? Well, for this one, it shouldn't be super bad because I know that the y equals 3 because that was this line, right? Y equals 3. So what do I need to do? I need to do graphing, I need to do substitution, I need to do elimination. It looks to me like it's positive 3, negative 2 when I look here. Positive 3, oops, other way. I did that backwards. Negative 2, positive 3. And because I graphed pretty accurately, I'm going to trust myself. But we'll also be getting into using substitution and elimination to do this. I would have used, in this case, substitution and substituted this right here to solve for x. When we use substitution and elimination, we pretend that those are equal signs to solve for x or y. All right, so that was our first whole slide together. Again, pause at any time you need. And I'm going to move to the next one. Okay, and I'm going to color code again. So I kind of gave myself room to manipulate these lines here. I'm going to put this in y equals 2y less than or equal to negative 2 plus x. Divide by 2. Divide everything by 2. So I get negative 1 plus 1 half x. So I'm going to put a dot at negative 1, and I have negative 1 half x, so I go down 1 over 2. Down 1 over 2. Okay, and then I look and I decide that I'm making a solid line. Okay, so I'm going to graph in that solid line. Well, that one wasn't so bad. And then I'm going to shade lightly. So if I test 0, 0, I get 0 less than or equal to negative 1, and that's false. Okay, so I'm going to shade on the opposite side. And again, I'm shading lightly, or I'm just doing this so I know what's happening. Okay, choose a different color because that helps me. I'm going to do the same thing where I'm going to get this into y equals mx plus b, just like I like it. If you like graphing the x and y intercept for these that are in standard form, please go ahead and do that. So y greater than 3 plus 5 halves x. Okay, so what I need to do, oh look, I have extra room to work, is put a dot at 3, and then I go up 5, 1, 2, 3, oops, I don't have enough room, so I'm going to go backwards, 1, 2, 3, 4, 5, and then over 1, 2. Oh, look, that's good because these crossed in the exact same spot, right? Oh, that was a really crooked line. All right, so I can already tell where my vertex is going to be, but I don't know where my feasible region is. So I need to just test 0, 0 in this case. So is 0 greater than 3? Again, that's false. Okay, so I would shade this area. Okay, and remember, the thing that I'm concerned most about is this overlap. So the only place they overlap, this light purple maybe wasn't the best choice, but is right here. So I'm going to erase my other scribbles. Okay, this is my feasible region. And I can tell right here my vertex is over 2, down 2. All right, that is it for today's lesson. Your homework is just on finding the feasible region and shading it in.